Welcome to my presentation on LBJ's compliance with the AAMI ST108 standards. You've received a handout with an overview of key points we'll cover, along with a short knowledge check quiz. Feel free to jot down answers as we go, or refer to the overview for assistance. We'll review the quiz together at the end. Let's get started. What is TIR-34? TIR-34, officially titled Water for the Reprocessing of Medical Devices, is a technical information report developed by the Association for the Advancement of Medical Instrumentation. It provided guidance on water and steam quality requirements for cleaning, rinsing, and sterilizing medical devices. Unlike standards, which are mandatory and require compliance, TIR-34 was a set of best practices and recommendations to help healthcare facilities maintain safe and effective water quality for medical device processing. While it outlined important parameters such as endotoxin levels, microbial contamination, and conductivity, adherence to TIR-34 was voluntary, serving as a reference rather than a regulatory requirement. What is ST108? ST108 is a comprehensive standard developed by the Association for the Advancement of Medical Instrumentation. It establishes mandatory requirements for water and steam quality used in the reprocessing of medical devices. Replacing TIR-34, which provided voluntary guidance, ST108 ensures consistent, safe practices by requiring compliance with specific parameters for water purity. These include microbial contamination levels, endotoxin limits, and conductivity thresholds. By transitioning from a technical information report to a standard, ST108 enhances patient safety, supports regulatory compliance, and provides clear, enforceable guidelines for healthcare facilities. Its implementation is critical for ensuring the effectiveness and safety of medical device sterilization processes. Transitioning from TIR-34 to AAMI ST108 involves new roles and responsibilities. A multidisciplinary water management team must be formed to ensure compliance with local rules and meet accreditation standards. STEAM now has a specific water quality category with set requirements for monitoring and maintenance. Guidelines have been expanded with more detailed water quality levels and performance criteria. There is a focus on regular monitoring, with clear duties to keep systems adequate and compliant. Adhering to ST108 keeps equipment in good working order by minimizing scale, avoiding residue, and prolonging the life of sterile processing systems. Sterile processing ensures the safe cleaning of medical devices for surgeries. Poor water quality can cause damage, biofilm, and ineffective cleaning. The AAMI ST108 sets utility water, critical water, and steam standards. Utility water is used for basic cleaning. Critical water requires advanced purification, and steam must be impurities-free to ensure safety and effectiveness. To comply, we have assessed our water system to determine treatment requirements. We are creating a plan to maintain compliant sterilization water quality, establish regular check frequencies, and ensure ongoing compliance and safety. As we continue to explore the AAMI ST108 water standards and compliance, let's take a closer look at the specific requirements for utility water, critical water, and steam. Each type of water has a distinct purpose, with parameters tailored to ensure proper cleaning, sterilization, and compliance. Let's begin with utility water. Incoming utility water refers to the water supplied to the department by the plant. At LBJ, this water flows through treatment components to become utility water, ensuring compliance with ST108. Utility water is used for non-critical cleaning and must meet the following limits. pH 6.5 to 9.5. Total alkalinity, less than 400 milligrams per liter of calcium carbonate. Endotoxin, not applicable for utility water. Bacteria should be less than 500. Color and turbidity. The water must be colorless, clear, and free from sediment. Chloride, limited to less than 250 milligrams per liter. Conductivity, must not exceed 500 microsiemens per centimeter. Copper, limited to less than 0.1 milligrams per liter. Total hardness, capped at 150 milligrams per liter of calcium carbonate. Total organic carbon, TOC, is not applicable to utility water. These parameters ensure that treated utility water provides a clean and reliable foundation for medical device cleaning processes, supporting compliance with ST108. Critical water is defined as water that has undergone extensive purification to remove impurities that could compromise sterilization processes. It is used in the final stages of medical device reprocessing, where the highest level of water quality is required to ensure compliance with ST108. Critical water must meet the following limits: pH 5.0 to 7.5, total alkalinity, less than 8 milligrams per liter of calcium carbonate to minimize residue formation. Bacteria and endotoxin, less than 10 to ensure microbial safety. Color and turbidity must be colorless, clear, and free of sediment to avoid visible impurities. Chloride, less than 1 milligram per liter to prevent equipment corrosion and contamination. Conductivity, limited to less than 10 microsiemens Siemens per centimeter, ensuring minimal ionic content. Copper, restricted to less than 0.1 milligrams per liter to avoid metallic contamination. Total hardness, less than 1 milligram per liter of calcium carbonate to reduce scaling and residue. Total organic carbon TOC should be less than 1. These stringent parameters ensure that critical water provides a pure and effective medium for sterilization, fully compliant with ST108. Steam is the final sterilization method used in medical device processing and steam sterilizers. It plays a critical role in ensuring that devices are free from contaminants and safe for use. To achieve effective sterilization and comply with ST108, steam must meet strict quality parameters. The following limits apply to steam: pH 5.0 to 9.2, total alkalinity, less than 8 milligrams per liter of calcium carbonate to minimize residue buildup. Endotoxin, not applicable for steam. Color and turbidity, must be colorless, clear, and free of sediment to prevent visible impurities. Chloride, less than 1 milligram per liter to protect equipment from corrosion. Conductivity must not exceed 10 microsiemens per centimeter, ensuring low ionic content. Copper, restricted to less than 0.1 milligrams per liter to avoid contamination. Total hardness, less than 1 milligram per liter of calcium carbonate to reduce scaling and maintain sterilizer efficiency. Total organic carbon TOC is not applicable to steam. By adhering to these parameters, steam ensures safe and effective sterilization, supporting both compliance with ST108 and optimal patient safety. LBJ is committed to ensuring high-purity water for its critical processes. To achieve this, LBJ is upgrading its water treatment systems with advanced features such as UV disinfection, circulating loops, and routine testing protocols. These upgrades, in conjunction with clearly defined roles for biomedical engineering, facilities, and SPD, will ensure both compliance and reliable system performance. The upgraded water system utilizes both critical and utility water pathways to protect equipment and ensure water purity. Our focus today is on the critical water pathway, which supports essential processes requiring the highest level of water purity, including final rinses and steam generation using stainless steel boilers. This pathway includes backflow preventer, prevents water from reversing into the incoming water line. Sediment filter, removes large particles. Carbon tank, eliminates chlorine. Water softener, reduces hardness. Reverse osmosis system, removes bacteria and toxins. UV light and endotoxin filters, ensure purity by killing and capturing bacteria. Critical water loop, circulates water for consistent quality. Biomedical technicians are essential in adhering to ST108 standards. They oversee water systems, service equipment, and log tests and procedures. This guarantees adherence to strict protocols. They are crucial in keeping water systems pure, extending equipment lifespan, minimizing downtime, and boosting system reliability. Their role is pivotal for success in AAMI ST108 compliance. Steam isn't mentioned, as facilities engineering handles that responsibility. To sum it up, LBJ's is actively transitioning to meet AAMI ST108 standards. By upgrading systems, conducting routine testing, and working together, we ensure compliance and enhance the efficiency of our water systems, benefiting the entire facility. Before we conclude, let's review key points about LBJ's compliance with AAMI ST108. This ensures high-quality water and steam systems to protect medical equipment and enhance patient safety. Critical water pathway supports high-purity tasks like final instrument rinses. Includes UV disinfection, endotoxin filtration, and a continuous circulating water loop to maintain consistent quality. Utility water pathway provides water meeting AAMI utility water standards for non-critical tasks such as general cleaning. Core system components: backflow preventer, stops treated water from reversing into the incoming line. Sediment filter or multimedia tank, removes large particles to protect downstream components. Carbon tank removes chlorine and chloramines, protecting reverse osmosis membranes. Water softener reduces hardness by removing calcium and magnesium, preventing scaling. Reverse osmosis system removes bacteria, dissolves solids, and toxins to produce high-quality water. UV disinfection eliminates remaining bacteria in the critical water pathway. Endotoxin filters capture dead bacteria, ensuring high purity water. Critical water loop circulates purified water through UV disinfection and endotoxin filters, maintaining consistent quality. Biomedical engineering's role monitors water systems and performs maintenance, documents testing and corrective actions, ensures compliance AAMI ST108, improving reliability and safety. Thank you for your attention. Let's move on to the knowledge check to reinforce these critical points. Please answer the questions on the knowledge check I handed out before the presentation. What are the purposes of the critical water pathway and utility water pathway? How does the reverse osmosis system improve water quality? Why is the water softener important in the water treatment process? What does UV disinfection do in the critical water pathway? What role does biomedical engineering play in ensuring compliance with AAMI ST108? What are the purposes of the critical water pathway and treated utility water pathway? Answer supports high purity task and non-critical cleaning tasks. How does the reverse osmosis system improve water quality? The answer is removes bacteria and dissolved solids and toxins. Why is the water softener important in the water treatment process? The answer is reduces hardness and prevents scaling. What does UV disinfection do in the critical water pathway? The answer is kills remaining bacteria for water purity. What role does biomedical engineering play in ensuring compliance with AAMI ST108? The answer is monitor systems, maintains equipment, and ensures compliance and safety. This concludes my presentation. The sources I referenced include AAMI ST108 2023, the proposed LBJ Water Management Plan, Ascend Labs Reference Manual, Biomedical Engineering Best Practices. Feel free to ask questions or share feedback. Thank you for your attention. That's all, folks.